Rolling. Let's go. So year 12 maths, we're going to continue our look at exponents. And the first thing we're going to look at are some examples of where you have negative powers. Again, power is another word for exponent, whatever you want to use. Remember that a negative power simply tells you that it's on the wrong side of the fraction bar, right? Very good job. So 3 to the negative second. The negative exponents tell you that it shouldn't be where it is. Where is it now? In the numerator or denominator? It doesn't look like a fraction. That means it's in the numerator, right? In the top. So it'll drop to the bottom where the exponent will become positive. And that leaves what in the top? 1. And then, of course, you still have to simplify the exponent. 3 to the second power is 9. Right? Now, when you have parentheses, that means you're raising everything to that power. So we can take care of the negative before we start raising things to the power, or you can just write it out with negative powers and take care of it that way. Most people would say this is a negative exponent. That means that the stuff inside is in the wrong spot. So the 2 shouldn't be on the top. The 2 should be where? On the bottom. The 3 should be on the top, which makes the exponent no longer a negative 3, but a 3. Everything just changed positions. Do you see what happened? And that again, it's because of the negative exponent. Then, of course, you have a parentheses to a power. That means take everything inside, raise to that power. And 27 over 8 is a perfectly good answer, even though it is an improper fraction. Okay? All right. The one you were asking about a while ago, 1 1/4 raised to the negative 2. So the fraction would invert, but we have an issue. 1 1/4. Can't work with numbers like that. You can't multiply with them or divide with them. You have to change them to improper fractions. Do you remember how? You take the denominator times the whole number, and then add that product to the numerator. So 4 times 1 is 4, plus another 1 makes 5, and then you put it back over the original denominator.
And why do you add 1?
Because there was a 1 in the numerator. You have to. That 1 still counts. In other words, 1 is 4/4. So what you're really doing is 4/4 plus 1/4, right? But there's a shortcut pattern for it. All right. Now, exponents negative tells us it's in the wrong position, so it should be 4 over 5 raised to the positive 2, which means just raise both of them to the second power, and there's your completed answer. Okay? So, you can't work with the 1 1/4. You must convert it first.
What do you do with the fraction's negative?
If the fraction's negative, go ahead and take care of the. Remember, the negative exponent's not gonna affect the sign. So if you have like negative 7 over 5 raised to the negative second, the negative exponent just tells you that the numbers are in the wrong place. It doesn't matter about the sign. So that becomes negative 5 over 7 raised to the positive 2. Then you can start evaluating the exponent. Negative raised to a second power makes a what? Positive, right? Any negative raised to an even power always becomes a positive, right? 5 squared is 25. 7 squared is 49. So there's your final answer. So again, it doesn't matter if the fraction is negative. All it does is take the numerator and denominator and switch them. It still stays a negative. Oh, hold on just one second. Yes?
Sorry, how would we get rid of the minus to the power and change it to...
Because you see this? It flipped over. Down here?
Yeah, 1 1/4.
Well, we changed it to 5/4, right? And that was raised to the negative 2, which means that should be 4 over 5 raised to the positive 2. So you just invert the fraction, and that changes the sign of the exponent. Because it's really, what you're really saying is we have 5 to the negative 2 over 4 to the negative 2, which tells you that it should be 5 to the 2 in the bottom and 4 to the 2 in the top. So if you want to write it that way, that's perfectly fine. It just means you're writing a little more. But if it makes it clearer, that's the goal. Okay? So you can write it like this with both of them raised to a negative power and then take care of the negative powers if you'd like. Yes?
When it's to the negative 1 and then you change size, do you just leave it as
Okay. Exactly. So negative 1 just turns to 5 over 4 to the first, and anything to the first is just the number you get. So it's just 5 over 4. Okay? Now we're going to see some more negative exponents on the next page. We're going to look at negative exponents with variables. So let's continue on. Do you think it changes the rules because they're variables? Guys? Do you think it changes the rules because it's variables? No. Rules stay rules. So, b to the negative 12. It's a negative exponent. That tells you it's in the wrong spot. If it doesn't look like a fraction, that means it's in the numerator. Where should it be? In the denominator. And then you leave the 1 over. Okay? Right? Now, let's see. So look at number 6. 3ab to the 5th, all raised to the negative 2 power. The negative exponent on the parentheses tells you that the stuff inside shouldn't be in the top. It should be where? On the bottom. Okay? Which leaves a 1 in the top. And now it's to the positive 2. Right? You're just inverting it. And then we'll square everything inside. Well, 1 squared is still 1. 3 squared is 9. A squared is a squared. And b to the 5th raised to the 2nd power is my favorite rule, b to the 10. Because it's, remember, when you raise a power to a power, you multiply.
When you're like sorting it out, can you do like 1 to the 2nd power over 3ab5 instead of like doing the whole thing?
Sure. Yeah. So if you want to do 1 to the 2nd power over 3ab to the 5th raised to the 2nd power, you bet.
If it's just like a number like 1, do you still have to put it in brackets?
Well, you really should until you take care of the power.
Okay.
Because it was brackets up there, it should be brackets down there. Just because sometimes it can be different. Now, I would never count it wrong if you did. Okay? All right? How about number 12? You want to see that one? It's a fun one. 4c to the 3rd over a squared b to the negative 1, all raised to the negative 1 power. Okay? Where do I start? Inside. Is there something I can do inside? Yes. That negative 1 exponent could go up to the top. It becomes 4b c to the 3rd over a to the 2nd. Why did I put the b in front of the c? Because it's alphabetical order, right? It's descending order. Anytime you have more than one letter in a term, they should be in alphabetical order. It's not technically wrong, but it's bad.
Okay, cool.
Okay? And then all of that is raised to the negative 1, which is going to do what? It's going to flip everything back. So 4b to the c to the 3rd goes to the bottom, and a squared goes to the top. Okay?
Oh wait, it's just a 1.
No, that's for the long thing. You just leave it, take the brackets away.
Right, that's it. Because it's an exponent of 1, so who cares, right? Look okay? So the same thing with number 11. You could do those, so. Okay? All right. Okay? Now, next. Surds. That's a stupid word. Roots.
These are cool because we were...
Which are fractional exponents. Right? Remember we talked about that? A to the 1/2 really means the square root of A. Now remember with roots, okay? If it's the square root of A, the square root is the smallest root you can take. So that is the only one where you don't have to write a number for the index. The index is just assumed to be a 2. So if you don't see an index, you assume to be what root?
2.
The second or square root. Now, any other root, you have to write it. So fifth root, you would have to write the 5 in there. Okay? But if you, and it is certainly not wrong if you write the 2 in there. Okay? Yes?
This is a really dumb question, but I haven't even seen a number like the 2 here.
Yeah, because they're all square roots, but yeah, you're going to have some that aren't here now. Okay? Now, again, if it's got the 2 there, that's what I was just saying. You don't have to write it. You assume there's a 2 there. But if it's any other root, you have to write it.
So it's the 5 root?
The fifth root of A. Mm-hmm. You've never had bigger roots than that? Square roots or cube roots? You can have square roots. You can have cubed or third roots. You can have fourth roots. You can have fifth roots.
That's why you don't call them square roots.
They're not all square roots.
They're not square roots.
Right. That's why they're just roots, not square roots. Because they can be anything. Now, pardon?
Is there an infinite number of roots or something?
Oh yeah, you can go on forever, but they'd be ridiculous.
Yeah.
Okay, at some point. Now, what happens if I have A to the 2/3? Now remember, it's still a root, and I know that because the exponent is a what? Fraction. Okay? But the denominator, so the denominator becomes the index, but what about the 2?
2
Is an exponent or a power. There you go. So this is the third root of A to the second. Or, remember, this is the one you can write in 2 different ways. The third root of A, all raised to the second power. And the way you write it is going to depend on what you have and the information that you have. Now, if it's just A, I don't care, because I can't do the third root of A squared anyway. Right? But if you can square it, so like say it was it couldn't be a square root to this power, but there are certain times when this notation is better, and certain times when this notation is better. And I'm absolutely sure they're going to give you examples of both. I'm happy either way. So, in other words, if you squared this A, and that allowed you to take the cube root of it, or the third root of it, then it's better to square it first. If you could take the cube root of it, it's better to take the cube root and then square it last. So, for example, say we have 27 to the 2/3 power. That's the cube root of 27 squared, or the cube root of 27 quantity squared. Now, if we squared 27, we'd get a huge number. And then we'd have to take the third root of it. But if I take the third root of 27, what's that? It's a 3, right? And then all I have to do is square the 3. So do you see that if it's a perfect whatever underneath, you don't want to square it first and then turn it into some horrible number.
Oh, yeah.
Right? You want to take the root first. So if you can take the root, you need to do it like this and take the root first and then square it.
And it will be the same.
And you'll get the same answer.
A number and comes on a road on a calculator.
Different. Let's see. For those calculators. Okay. So the 9 was not part of the base, so only the A went under. Hold on. Okay. So that's something we might have to get into later, but I don't know yet.
That's a later issue.
It's a later issue for right now because we don't have to do it right now. Okay? All right. Good job. So we have to convert back and forth. Now, they do give us some operations involving radicals that we need to talk about. We need to talk about how to multiply radicals. Surds, okay? You just want me to use that word, don't you? Radical is a surd. Radical, root, surd, all mean the same thing. Okay? To multiply them, first, keep the radical. It doesn't change. And a square root times a square root is still a square root.
Wow.
Not a fourth root. Don't multiply the indexes. Okay?
Oh, because it's the inside stuff.
Multiply the radicands. It's a good thing I did use those terms, right? What's the radicand? The stuff inside, right?
See, how my language doesn't matter. I'm like the little bit things.
The little bit things, yeah, those
I'm
things.
not gonna know what that is, but that's fine.
That's all right, as long as you do. Okay? And then simplify radicands is what it's called, if possible.
Rat cannot.
Right cannot find
Okay? Don't y'all start giving me trouble now. Okay.
Okay.
Oh, good. It's a good thing because I can't say your first name.
Hold on. What are you looking at? My second name either.
Oy. All right. It's even worse. To it, so we can get out of this section at some point. Okay? So here we go. Let's just multiply a couple of them.
They want us to do it like convert it to fractiony.
The screen's
closed.
Your screen has vanished and I have not finished writing.
How'd that happen?
Wait, what was this stuff?
There we go. I'm back. Okay. They want us to change it to fractions and add the fractions?
They
Nah.
want us to do like a 3 over 2 when it's like other stuff.
I don't see any reason to.
So we can just chill.
Well, let's see. As long as we can get the same answer, I don't see any reason to because that's crazy. All right, now, here we go. Are we ready? So we have the square root of a to the third times square root of a to the 7. Okay? Guys, which is the square root of a to the third times a to the 7. And when I'm multiplying with exponents, what do I do to them? Add them. So that's a to the 3 times 7, which is the square root of a to the 10th. Now, go to the back of the book and tell me what they have as an answer. Should be maybe a to the 5th. A to the 5th. Let me tell you why. How. To simplify a radicand with an exponent. So this is what I was trying to avoid teaching you just a second ago, but here you go. You're going to get it. Okay? All you simply do is divide the exponent by the index. And remember, the thing I call the index is that number that's in there. And I don't know another name of it, so we'll see.
Is it going to be a B or is it just a B?
So what number is inside there, if there is no number? 2, you betcha. So it becomes a to the 10 divided by 2, which is a to the what? 5th. And since it divided evenly, the radical is gone. That means a to the 10th is a perfect square. If it doesn't divide evenly, you have to do that thing I did a while ago where you break it into numbers that will divide evenly. Yes?
At the very top,
Uh-huh.
when you're timesing a cubed and a 2 power 7.
Right.
So do we have to put times?
No, you don't have to write all that out. I just wanted to show you all the stuff that was happening. Yeah.
If there was a long question where we would have to write that out, can we just get exact answer?
There should never be an option. Yeah, you could go from this straight to this, and I would be perfectly happy with you.
I don't even think about it.
Right? But I just like to show every step while I'm doing the notes. Okay? Good question. All right. Now, again, they're just exponents, so just add them. Now, look at number 4. 4 looks different, guys. But it's just a matter of perception. Don't freak out. if you're multiplying a radical times some other thing, what do you write? So if you were doing x times 9, for example, what would that be? Yeah, x times 9 would be just 9x. Well, the fifth root of a to the third times a is just a times the fifth root of a to the third. This a is like a whole number. It's not underneath a radical, so it can't affect the stuff that is under a radical. Right? So be careful.
Wait, can we do number 2?
Okay.
I'm using the index.
Woo, that was fun. Number 2.
With the index that you see behind it.
Oh, sure. Number 2, we've got the third root of a to the fourth times the third root of a to the fifth. Well, the third root times the third root is still a third root, and it's a to the fourth times a to the fifth, which just means a to the ninth.
Which is...
And can I divide 9 by 3?
Yeah.
Yep. So that's a to the 9 divided by 3, which is just a to the third.
Wait, so you leave the index aside?
Yeah, the index, remember, a square root times a square root is still a square root. A third root times a third root is still a third root. You can't take it, you can't change the x. The index never changes with a radical unless you can take the root, like we did here.
And then,
So if you had 2 that were kind of multiplied that had different indexes.
Yes, you cannot do that.
Okay.
So a fifth root times a fourth root
Just
can't be done.
it just says.
So you just leave it the way it is. Or you could stack them side by side if you wanted to.
wait, so a fifth root and a second root, they just...
You can't multiply them together. They have to have the same. They have to be
So
alike.
question 3 does it just stay the
That's
same?
4 times.
So the fourth root times the square root just stays the fourth root times the square root. Now look in the back and see if they could shove them to side by side, but you cannot multiply them.
They said 8 is 6.
A to the sixth on number 3.
Are they indices?
Need to talk about it. So you can't multiply them using the same rule that we were doing where we were just multiplying the interiors. So what you have to do is you have to convert to fractional exponents.
It also says that number 4 is 5 root a to
Oh, what's going on?
Yes, because they use fractional exponents at the end. So that's what they're going to do. So let's look at those using fractional exponents instead. You can simplify them if you use fractional exponents. That's very unusual. All right, so the fourth root of a to the third times the square root of a to the third. You can't do those the way in the format they are. This is number 3. Okay? On page 14. Okay? Now, but if you change those exponents into fractions, you can add fractions, right? So that becomes a to the 3 over 4 times a to the 3 over 2. Be careful. Yeah.
What says to express it in index form?
Yes. Oh, does it?
Yeah. Well, that's
No, it doesn't. But oh well. Okay. So you can change them to exponents, the exponents to fractions. Now, do they have the same base? Yes. So we keep the base, and what do we do to the exponents? Add them. You bet you do. Which gives you... we have to have a common denominator. For 4 and 2, the common denominator is 4. Okay? So that becomes a to the 9 over 4.
Hold on.
To add fractions, you have to have a common denominator,
Yes,
right?
just multiply this.
So 3/4 plus 6 over 2. What would you multiply 2 by to turn it into a 4? So, oh, sorry, that was 3. Yeah, so you multiply them both. Yes. Yeah. Okay, now, guys, remember? Okay, guys, Focus. Let's go back together. So those can be done using using fractional exponents, and that's what they want you to do. So to multiply or divide, I think I just like writing the word surd. Okay? Step 1, change to fractional exponents. It does allow you to do more, but anyway. All right? Then use add or subtract rule. Add if you are what? Multiplying. Subtract if you are what? Dividing. Okay? For exponents, right? Add or subtract rule for exponents. So those two simplification rules. If you're multiplying, you can add them. If you're dividing, you can subtract them. Change to fractional exponents, and then use your add or subtract rules. Okay, so like we just did. Hold on, we'll do another one. Go ahead. So, for example, we have a to the second divided by the fifth root of a to the fourth. That becomes a to the second divided by a to the what? 4/5, excellent. Am I dividing with the same base? Yes. So that means I can take those exponents and simply subtract them. Yes. X to the fifth divided by x to the third is x to the 5 minus 3. Yes, we've done this, right? There just happen to be fractions this time. So 2 minus 4/5 gives us a to the...
Wait, I just had it.
This is why it's good when students listen to me, not do your own thing while you're doing it. Pardon? 6/5? No, I believe you. I don't know.
Why? Oh, so you kind of fraction.
Yeah. 6/5. Okay? All right. So, okay? Now, but, let's move on. The next section is combined roots, powers, and coefficients. Okay? Shh, guys, come on.
Can you have a fractional exponent when it's already in a surge? Like if you had like root something and it would be like a with a fractional.
Technically, if you can take the root of a number, then the radical will go away. So, for example, look at number 1 on page 15. We have the fourth root of 16a to the 8th. Now, you could change this into fractional exponents, but then you wouldn't know what to do with it. So, if you're going to simplify it, right, we're not multiplying or dividing it. We just want to simplify it. So, we need to simplify it as a radical, as a root. So, the fourth root of 16. What number times itself 4 times is 16? 2. So the fourth root of 16 is just plain old 2. With exponents, remember, I told you the rule for that. The fourth root of a to the 8th is a to the 8 divided by 4. You just divide the exponent by the index. So that gives me a to the what? Second, right? Because 8 divided by 4 is 2. Okay. So you will always have to be asked to simplify some radicals. Let's look at another one just so everybody's good with this. It's not difficult, but you might not have done it in a while. Hopefully you've done it.
Can you show me calculator?
Yeah. Yeah, probably. I don't know.
4?
The cube root of 64 is what? 4. Oh, definitely the number part. Yeah. But you just can't do the exponent. And then that's a to the 9 divided by 3, right? Does everybody see where I'm getting those numbers? 9 divided by 3, which is just a to the what? Third.
So it's 4a.
4a to the third is your completed answer. Okay? Now, I want to look at number 4. And what I want you to do is turn to the back and tell me what the answer is they give you for number 4 so I can show you how to simplify this best. Is it 7a to the 5th with square root of a?
7a, 11 over 2.
Ah, okay. Good. That's...
Or 7 root a to the 11.
There we go. So 7 root a to the 11 can't be simplified because 11 won't... What is the index here? 2. 11 won't divide evenly by 2, so they just left it alone. Or they turned it into a fraction.
That was one of the options.
Yeah. Or they just turned it into a fraction. 7a 11 over 2 to the 11 over 2 power.
Oh, yeah.
Yeah? They're being nice to you.
I like that way better.
You're being very nice to you. Okay? So if you can take the root they're expecting you to. All right. Look at number 6. 25 a to the, it's not bad. 25 a to the 4th, because this is the kind of stuff they test you on. They don't test you on x to the 5th times x to the 3rd. This is what they're going to test you on. All right. 25 a to the 4th raised to the 1/2 power times, I hate using x as a multiplication, 8a to the 6th, because x is a variable. And I know y'all just write them differently.
Yeah.
Oh, why don't you just replace the multiplication x with a dot and be done with it?
Writing a sentence and you're like, dot, little dot.
I don't know, I just learned that.
It's a dot. It's floating in the middle, so you know it's not a period. All right. Now, can I simplify? I can multiply those, but look, the exponents are different. Okay? So be careful when you're multiplying. So the best thing to do is see if I can simplify them and get rid of the exponents in the first place. 25a to the 4th, that's the square root of that, right?
Yeah.
Times the third root of 8a to the 6th. What's the square root of 25? 5. What's the square root of a to the 4th? A to the 2nd, right? Because you divide. Okay, times. What's the cube root of 8? 2. What's the cube root of a to the 6th? A to the 2nd, because remember it's divide. Because it's a to the 6 over 3, right? Okay. And 5 times 2 is 10. A squared times a squared is a to the 4th. Okay. All right. Okay. We will eventually get through powers. So, I expect you to be able to do anything up to page 15 by now. Okay?
You expect a lot, like.
I expect a lot.